Have you ever stopped to think about what's actually happening inside your computer when you, say, open up an app? It all comes down to memory. But, it's not just one kind. Today, we're going to pull back the curtain on this hidden partnership between your computer's two main types of working memory, SRAM and DRAM.
It feels a little weird, right? I mean, why make things so complicated? Why not just pick one kind of memory and, use a whole bunch of it? Well, it turns out there's a really fascinating reason. And it all comes down to this secret teamwork that pretty much makes our entire digital lives possible. So, to really get this partnership, we've got to zoom out for a second. Before we dive into what makes SRAM and DRAM tick, let's just get a quick bird's eye view of how a computer's mind, its memory, is actually set up. Okay, so at its very core, computer memory is just digital storage. Think of it like a huge library, but it's organized by speed. You've got your long-term archives, that's secondary memory, like your hard drive. Then you have the main reading room, which is primary memory, and that's what we're focused on today. And finally, there's this tiny, super fast little desk right by the door for whatever you need right now. That's cache memory. All right, now let's zoom in. Inside that primary memory category, we find the real star of our show, RAM. This is the computer's active workspace. This is where all the magic is happening, moment to moment.
So RAM stands for Random Access Memory. And honestly, the best way to think about it is as the computer's workbench, or maybe its desk. This isn't the long-term filing cabinet. Remember, that's your hard drive. No, RAM is the space where the computer lays out all the tools and papers and data it needs for whatever it's working on at this very second.
And here is a super important detail. RAM is volatile. What does that mean? It means as soon as you cut the power, poof, everything on that workbench is just gone, wiped clean. It needs that constant flow of electricity to hold on to information, which is exactly why you always have to save your work to the hard drive before you shut down. All right, now that we've got the basics down, let's meet our first key player. This is SRAM, or static RAM. And for our little story here, just think of SRAM as the elite, lightning-fast sprinter of the memory world. The secret to SRAM's incredible speed is all in how it's built. It stores every single bit of data using a circuit made of 6 transistors called a flip-flop. The easiest way to picture this is like a physical light switch. Once you flip it to on, it stays on. You don't have to do anything else. That's why they call it static. It's just stable.
So, because of that super stable design, SRAM is just blazing fast. It doesn't need to be constantly reminded or refreshed, which saves a ton of time. But, and this is a big but, that complex 6-transistor setup makes it really expensive and not very dense. You can't pack much of it in. That's why it's only used for these small, critical jobs where speed is absolutely everything, and that job is being cache memory.
Okay, so if SRAM is our sprinter, then every good team needs an endurance athlete, right? So let's meet our second player, DRAM, or dynamic RAM. This is our marathon runner.
Now, the design here is totally different. Instead of that complex flip-flop thing, DRAM is super simple. It just uses one transistor and one tiny little capacitor to store a bit of data. You can imagine the capacitor like a tiny, leaky bucket. It holds an electrical charge, and that charge represents your data, a 1 or a 0. Now, because that little bucket is leaky, the charge naturally fades away. So the computer has to constantly go back and refresh it, basically top it off with electricity hundreds of times every second just to keep the data from disappearing. This whole process makes it dynamic, but it also makes it slower than SRAM. The huge advantage though, its simple design is way cheaper and lets you pack a ton of memory into a tiny space. And that is why DRAM is perfect for your computer's main memory.
Okay, so we've got the sprinter and the marathon runner, the expensive speedster and the affordable workhorse. Let's put them in the ring, head-to-head, and see how they really stack up against each other.
When you really boil it all down, these are the two differences that matter the most to us. SRAM gives you just mind-blowing speed, but it costs a fortune. DRAM, on the other hand, gives you good, solid performance and a ton of capacity for a price that we can all actually afford. This table just lays it all out so perfectly. Take a look at refresh needed. A clear no for our sprinter, SRAM, and a definite yes for our marathon runner, DRAM. Now look down at density. SRAM is low density, but DRAM is super high density. That's why you can have 16 or 32 gigabytes of it in your laptop. You can see how their final job, their usage, is a direct result of these fundamental differences.
So after that whole showdown, you might be thinking that these two are rivals, right? Like they're competing for the same job. But the truth is, it's the complete opposite. Their differences don't make them competitors, they make the absolute perfect partners. This is how they form a team. Your computer uses a tiny amount of that ultra-fast SRAM as a cache. Think of it as a high-speed VIP waiting area for the massive, affordable pool of DRAM that acts as the main memory.
Okay, so here's how the teamwork happens in real time. When your processor needs a piece of information, it doesn't go straight to the big, kind of slow DRAM. No, first, it checks the tiny, lightning-fast SRAM cache. If the data it wants is already there, that's called a cache hit. It grabs it almost instantly. Game over. If not, no big deal. It just goes and gets it from the main DRAM, but here's the clever part. It also makes a copy of it and puts it in the SRAM cache, because it's betting you're probably going to need that same piece of data again very soon.
And that right there, that's the whole secret. It's not about which one is better. It's about using the unique strengths of both. By combining the pure, raw speed of SRAM with the huge, affordable capacity of DRAM, we get a memory system that gives us the best of both worlds. Performance that feels super snappy without costing an arm and a leg.
So, the next time your computer or your phone just feels fast, you'll know to thank this really elegant hidden partnership. Kind of makes you wonder, doesn't it? What other secret teams and hidden partnerships are working together inside all the technology we use every single day? Thanks for tuning in.